Hi guys. So in this video, I will be explaining you about some of the important data structures of array. Okay, so array is one of the fundamental data structure which is asked among top product-based companies also as well as service-based companies also. So let's understand and see like what all algorithms are present within arrays data structure, and then we will be understanding in depth of it, like what type of problems can I see by looking at those algorithms, like whenever I get into certain problems, how will I understand which algorithm I need to make use of? So there are multiple types of algorithms in array. So let's get started. Algorithms present within array. So first is sliding window. Okay, so you might have heard about the sliding window algorithm, right? So there will be a window size of a particular size, let's suppose k size. So k can vary, it can be 2, 3, 4. Okay, so it may change in size. So you have to shift the window as per the requirement. So let's suppose I may want to calculate the maximum sum within a given window. So I need to shift the window. Okay, so in those type of scenarios, it will be used. Then prefix sum approach is there. So it reduces the time complexity while calculating the subarray sum from O of n cube to O of n square. Okay, so those type of things we'll be explaining. Then two pointer approach is very important approach, like left pointer, right pointer, how we can make use of it. Then Cadence algorithm, it is also used to calculate the sum, but it reduces the time complexity to O of n from O of n cube. So this is also very important. And then at last, I will be explaining you like what are the commonly asked arrays interview questions. Okay. So in this video, I will be focusing on sliding window first, and then I will be coming up with lots of next videos consisting of prefix sum, two pointer approach, Cadence algorithm, and commonly asked arrays questions. Okay. So I'm not putting everything in one video so that you will not get confused or overwhelmed like whether I will be able to do it or not. So I will be going step by step. Okay. So first topic will be sliding window problem. So let's understand that. So what is sliding window? So let's understand that. Okay. So how sliding window works. So what type of problem sliding window is solving is basically whenever there is a window that we have to define. So what type of problems can we think of that actually consist of a window size? So whenever the question arises like subarray, okay, for a string contiguous subarray sequential part I need to go like one by one in a sequence I need to go. Okay, so we don't have freedom that we can skip the particular index, like from first I am hopping to third index, I'm hopping to seventh index. This freedom is not there with me. I need to go sequentially step by step. And in that scenario, sliding window helps us a lot in reducing the time complexity. Okay, so what type of problems sliding window solves? It efficiently solves problem that involves defining a specific window, okay, or a range in a given input data. It can be arrays of strings, it can be array of integers, okay, and then we have to move the window right or left depending upon our requirement, and then we have to provide certain kind of inputs for the given kind of operation. So sliding window helps us to resolve a lot of problems where time complexity is the major issue. Okay, so whenever we need to find a subarray sum, there what will be happening? So we every time we have to select first index, then we have to go for next index within a given size of k. Again, we have to shift in a window. Again, it will go from second to last. Again, third to last till it reaches the end of the array. Okay, so there will be a window size, right? So what will be the brute force approach to solve this sub array sum? That also I will be explaining you through code. Okay, so these type of problems basically sliding window solves. So finding sub-array with a specific sum, finding longest substring with a unique characters. So this technique is used when we need to find a sub-arrays or substrings. So those kind of things sliding window helps us to resolve. So let's get started with some questions. Okay. So this is the question that we'll be understanding with brute force approach and then through sliding window. Okay, so finding maximum sum of subarray with a given k size fix. So some k size is given to us, which is a fixed size, let's suppose 5 or 6. And based upon that, we need to find the maximum sum of that subarray. So how can we calculate? Let's get started. I hope you can see my screen now. So here, if you can observe, so here I've taken one array, okay, and I've passed the integers present within the array like 1, 2, 6, 2, 4, 1. You can take of any size. So I'm considering window size of 3. Okay. So if I consider first 3, like the maximum sum will be how much? 6 plus 2 plus 1 is 9. Okay. Then I'm going to next window. Next will be 10. Okay. Next window's maximum sum will be 10. Then I'm going to third window. Maximum will be 12. And then I'm going to last window. It will be 7. So maximum is 12. Okay. So this will be the output for this. Okay. So now this is the window size basically, and then I'm creating one method for that. I'm passing array as well as the window size. Okay, then I've calculated length. Then I've kept the max sum value, which is 0. I have to calculate the maximum sum, right? So there will be two variables that I have to consider in brute force approach. I'm doing brute force way. Okay, so in brute force approach, first loop will be going from 0 till the entire length of the array. Okay, and second loop will be starting from the current ith value to k plus ith value. Okay, because here if you try to observe, if I is suppose, let's suppose here, so j will go till what point? J will go this index plus the k value, which is the size of the window. So this index of I will be here 1. So I need to go to I plus k position. Okay, so I position is 1, so k plus I will be 1 plus k, which is 3. It will go to 4. So 0, 1, 2, 3, 4. Okay, so it will be less than this. So 262 will be considered. Okay, so like this, it will go one step at a time. So when I is going to here, then j will go to k plus I. If I is here, then k plus this position. Okay, so each and every time, if you observe, j will move from the current ith index to k plus ith index, and we have to put that condition also, like j should not extend more than the length of the array, otherwise index out of bound exception can come. So that condition also we need to apply. So here if you can observe, I is starting from 0 till the entire length of the array. Okay, then I've put subarray window sum as 0. Okay, why I've put, because we need to calculate the sum in each and every window. Okay, and then we have to compare like what is the maximum sum amongst all the subarray windows. Okay, then I'm running a loop from j equal to I to k plus I, and I'm putting the condition also at the same time that k plus I should not be greater than the array dot length. Okay, it should be less than array dot length. And then I'm doing j plus plus. So at each and every instance, if you observe, this subarray window sum is being calculated. Okay, for each window, and I'm adding it into the subarray window sum. Subarray window sum equal to subarray window sum plus array of j. So it will calculate the sum over a particular window and it will be put over here. And then I am calculating the maximum sum. What's the maximum amongst the current subarray window sum and the maximum sum? So here it will help us to calculate the maximum sum amongst all the subarrays. Okay, so like this, it will keep on moving till the length of the array, and then it will help us calculate the maximum sum of a particular subarray window. So after execution of this entire method, it will give us the maximum sum as 12. Okay, so this is the way basically it will work. So I hope you understand. And you can do it through dry run as well. If you do dry run of this code, you will get to know like how it is being working internally. Okay, so I hope you got, like, I don't need to go to each and every values line by line through dry run. I don't think it is required. It's very much simple to understand also. So I is moving from 0th index to entire length, and j is moving from the ith value to k plus ith value. So you can imagine now. So I have already given you the clue like how to think in this. Okay, so let me run it once. So I should get the value as 12. Okay, so here, if you observe, maximum sum of given subarray is coming as 12. And how it is coming, I've already told you. Okay. So now I will tell you, like, currently what's the time complexity of this? Like, a time complexity will be O of n, okay, into O of k plus I. So, okay, so j is also moving, right? So it's O of n into O of n. It's O of n square time complexity. Okay. But we have to reduce its time complexity, right? So here the length of the array is very small, so time complexity is of not much use. But if array length is too big, so will it be scalable enough? No, right? It will not be scalable enough because time complexity is so high, and if it contains millions of data into an array, so it will take a lot of time. Okay, so it may take exponential amount of time as well. So we need to reduce the time complexity. So can we reduce its time complexity to O of n? Yes, it's possible with the help of sliding window approach. Okay, so in sliding window, how it is being done, let me show you once through a graphical approach once. Okay, so here what is happening in sliding window, I'm taking one example like 126241. Okay, so current window size I'm taking as 3. Current sum is 9 because the first 3 values, index values, sum up to 9. Okay, so first current sum I need to store it up to compare with other windows. Okay, So I have stored the first three elements sum as 9. I have stored it in a particular variable, and maximum sum as of now is 9. Then we have to move the slider. Just like there is a window, right? There is a slider window is present, which slides as per you sliding it. Okay, so similarly here also it works the same way. So first it was at first, second, third index, 0, 1, 2 index. Now it will slide the window to the next index. Okay, so 0th index will go to first, first will go to second, second will go to third. So previously it was 0, 1, 2, now it will be 1, 2, 3. So window has been slided, okay, by 1 unit. So here if you observe, the current sum will be 2 plus 6 plus 2, which is 10. And maximum sum is will be updated now. Previously the maximum sum was how much? 6 plus 2 plus 1, that was 9. Okay, so now it has been updated to 10 current sum. So now maximum sum will also be updated to 10. So now it is again sliding to the sliding by 1 unit. So after the next sliding, it is the next three elements will be 6, 2, and 4. If you can observe over here, 6, 2, and 4. These three elements will be coming as a next three index. So the value of this will be, let me show you, the value of this will be what? 6 plus 2 plus 4 is 12. So previously was 1 to 6. The value was how much? 9. Okay. Next was 262. Okay, so current in window value will be 10. Okay, next will be 6 to 4. Okay, for this it will be 12, and then at last it will become 7. So what's the maximum sum of a given subarray window? It is 12. So answer will be 12. So like this, the sliding window will work. It will just update the sum. We are not looping it the entire particular window. We are not looping it again and again. Okay, so it will just loop once and it will just update the sum. That's it. So it reduced the usage of one for loop, right? So if one for loop is being reduced, so time complexity being reduced by O of n also. So it will be O of n, now not O of n square. Okay, so like this sliding window problem is happening. It is just shifting the window and updating the current sum to find the maximum sum. So this is the approach basically for sliding window. So here what we are doing basically, we are leaving the first index which was already there in one window, and then we are adding the next particular index position in the current window. So this is the approach that we have to apply in the code. Okay, so we have to leave the last one. So what we have to do, first we have to calculate a sum of this, which was 6 plus 2 plus 1. Then what we have to do for sliding, we have to omit the first index. Okay, and then we have to take into consider the next index. So what is the current sum? We have to remove the last calculated index, and then we have to add the next particular index position value. Okay, so let me show you in the next slide. You will get to know much better way. So basically there are two types. Okay, fixed size and variable size sliding window. So mostly the questions asked is from fixed size only. Variable size is just changing the size based upon our requirement. It's not fixed size. Okay, so mostly the questions asked based upon the fixed size only, not variable size. Okay, so fixed size sliding window is what? When we have to find the size of the windows required, say k, and we have to compute the result for the first window, okay, including the first k elements. Okay, and then after that we have to use a loop to slide the window and compare with the current sum which has been calculated. So this is the way where fixed sliding window works. Okay, then variable size, we increase the right pointer one by one till our condition is becoming satisfied. Okay, at any step, if our condition does not match, we need to shrink our window by increasing the size of the left pointer. So this is actually the variable size sliding window. So in fixed size sliding window, what is happening? It is increasing in one way only, but in variable size sliding window, it is being increased by both the ways. Okay, it's variable. Okay, so again, when our condition gets satisfied, we are increasing the right pointer by one, and then we are following the step one, step two, again and again, again and again. So this is the variable size sliding window. I hope you got a concept of it. Okay, so here if you can observe, we have considered an array like 5, 2, -1, 0, 3, and value of k is 3, three-side window, and n is 5. Number of elements are 5. Okay, so here if you can observe, the current sum is equal to the window sum. Currently the current sum is equal to window sum. And second, when I have slided it by 1, the current sum becomes window sum, which was already calculated up. Okay, plus we have to remove the first index value. okay, which was already calculated. So we have to remove this. So -5. Then we have to add the next index value, which is 0. Like that, we have to calculate. So here window sum is getting calculated. So now I will compare also parallelly which current sum is more, the last calculated current sum or the current window sum. So which one will be larger? We need to store it in a particular variable. Okay. Then again, after sliding, we need to again calculate what is the window sum as of now. Okay, previously. Then we have to remove this -2 part, which was calculated here. So if you can observe here, what was there? I was removing this 5. Okay. I was removing this 5 and I was adding 0 to the current window. Okay. And then here what is happening, I'm sliding the window now to next particular 3 indexes. So I will remove 2 now from my current window, and I will add the next index value, which is 3, and I will check what is the current sum. Only this is the logic. There is no rocket science. It's very simple to understand. Just we are sliding the window. I am removing the last calculated index value, which is the first position of that window, previous window. And then I'm adding the next particular index value, which is coming under the new window. Okay. So like this, it is getting calculated. I hope you are getting the clarity on this. Okay. So now let me show you through code as well so that you will get more clarity on it. So here, if you can observe the same values I have taken for array, which I have taken for the brute force approach, k equal to 3, and I'm calling this method. So I've changed the method name to sliding window basically. So this part is same, calculating length and subarray window sum is 0 currently. So I've taken first window sum because I need to compare this sum with the next window sums. Okay. So for that, I've calculated the first window sum. So whether it's how much is the current sum. So here, before actually doing this, you can check like whether the k size is smaller than the array dot length or not. If k is greater than the array dot length, then it's not possible to calculate a sub array sum, right? So that check you can put it by your own. So here I have just written the main logic. So first I have to calculate the current sum starting from 0th index to k. So I'm assuming array dot length is greater than k. So I have calculated a sub array sum till the kth position. So k is 3. So first 3 values are calculated as 9, which is my current sum. Then what I am doing, I am storing the sub-array window sum, current first sub-array window sum to the current sum. Okay. And then after that, I will compare like which one is maximum. Okay. So what I'm doing now, current sum, I'm updating over here, starting from k. Okay. So why I'm starting from k? Because the loop has already run from 0 to k minus 1. Okay. 0 to k minus 1, it has already run because it is less than k. So that means it's running from 0 to k minus 1 position. K is 3. So 0 to 2, including. Okay, so 0, 1, 2. These 3 indexes will be used for calculating the first sub-array sum. And then I'm starting from kth position till the length of the array. And then what I'm doing here, try to observe this. This is very important. This is where only sliding window is happening. So if you observe in this particular line, I am taking current sum. I'm removing the first index which was calculated. So array at j minus k. So jth position will be how much? Is it at third position, which is 0, 1, 2, 3, this value. This value, third index minus k. Okay, so k will be here how much? 3. So it will become 0. So first particular index will be omitted out. Okay, and then it is adding me the next particular index, which is the j, which is 2. Okay, so first window was this. Then after that, I'm sliding my window to this. Okay, so to slide my window to next window 262, what I have to do? I have to remove the first one. One I have to remove, which is at first index, and then I have to add 2, which is the next index value to the current window. So that I have added. So this is the basic logic that I have to write for sliding the window. Just one particular line. Okay. And it will help us to calculate with O of n time complexity. Okay. And then what I'm doing, I'm using subarray sum variable, which I have already taken above. And then I'm calculating the maximum of this subarray sum with the current sum. So why I'm doing this? So let's suppose all the arrays are of negative values, but here subarray sum is 0. So 0 will be greater than all the negative values sum, right? So that's why I'm considering subarray window sum as 0, and I'm comparing the maximum among this subarray window sum and the currently calculated window sum. So based upon that only, I will calculate like what is the latest maximum sum. And then what will be the latest maximum sum will be printed over here, or you can return it back to the main method depending upon your requirement. So like this, it will keep on moving. So again, the next iteration, j will be equal to k, j less than ln j plus plus. So j will be again increased by 1. Okay. So in the next stage, k will be how much? J will be k plus 1. Next value it will move basically. So it will go to 4. Okay, so it will start from here then. So what will happen if we start from here? It has to remove the last index. So this will be the next value. Okay, so this will be the next window. So for calculating the next window, what will happen? It has to remove the 2 and it has to add 4. Okay, so like this, it will keep on sliding the window. I hope you are getting the concept, right? So like this, it will keep on rotate. It will keep on sliding one by one window. Okay. So I hope you got the clarity on this, like how it is being worked internally. Okay. So this is the way that we have to work with while using the sliding window pattern problems. Okay. So sliding window pattern problems generally comes when we have to work upon sub-arrays or substring where there is contiguous sub-arrays. Some we have to calculate, okay, maximum, minimum, those kind of things. So where there is a sequence we have to focus upon. We can't hop by one index, two index, three index. We have to be contiguous. We need to go one step at a time, window by window. Okay, we can't hop like two index ahead, three index ahead. We can't do dynamic allocation. We can't do like that. And in that scenario, sliding window works the best. Okay, so I've given you some problems so that you will get an idea like in which type of scenario sliding windows will be working upon. So here, if you observe, these are the main problems where sliding window will be working. First, finding subarray with a given sum, okay, in the array of non-negative integers. Here, these type of problems can be solved with sliding window. This is for your practice, basically. Second will be smallest window that contains all the characters of string itself. This is also a very important problem with sliding window. Third is length of the longest substring without repeating characters. Okay, so we have to calculate the length of the longest substring without repeating characters or with repeating characters. That also can be done with sliding window. Then count of distinct elements in every window of size k. Every window of size k, we need to calculate how many distinct elements will be there. That also can be done with sliding window. And then maximum consecutive ones. So it is of various type of problems are there for maximum consecutive ones. It is from lead code basically. So let me show you so that you will get the idea. So here, if you can observe, this is the question that was asked to me in Altimetric as well. So this is very important for interview also. Maximum consecutive ones. Okay, so this question I have added. So it has to be solved with the binary search as well as sliding window. Okay, so here what is there? Given a binary array nums, it is given to us, and an integer k, we have to return the maximum number of consecutive ones in the array. If you can flip at most k zeros. So k is given as 2. I need to flip at most 2 zeros consecutively. Okay, and then we have to find a maximum number of consecutive ones in the given array. So whenever it is going over a particular window of 2, 2, let's suppose, okay, so the wherever zeros will be coming, at most k zeros I can flip. Okay, so here it is given with explanation, so you will get to know when you will go through it. Okay, so it is going window by window. Okay, window by window it will be going, and then it will show like if you flip these values from 0 to 1, it will give the longest subarray. Okay, maximum number of consecutive arrays will be calculated. Okay, so this is the question basically. It's very important question. Try to do it by yourself. If you find a detailed solution for this, do let me know. I will create a separate video on this video as well. So in the next video, I will be discussing certain other algorithms as well. So sliding window is very important, and it is asked in interviews in product-based companies also, as well as service-based companies also. So practice it as many problems as possible. Okay, on sliding. So we'll see you in the next video. Till then, it's Devjit Roy signing off. Bye bye.